Hello student, welcome to VidyaNest. Those who have followed last class, they know that we have already started limit. Last day what we are taught in short span, I am reminding you. We got the definition of limit. We got the definition of limit that fx minus L less than epsilon if x minus a less than del, then limit x tends to a, fx is equal to L. We got that epsilon delta definition of limit. We got the conception that if right hand limit of a function is equal to left hand limit of another function of same function are equal, then limit exists at x is equal to a. Against it, we had chosen one simple example. What? Say limit x tends to 0 mod x by x. Last day I told you that if you get mod x or root or box x, this type of function, then instead of finding the limit directly, first you check whether limit exists or not. Now, how to examine whether limit exists or not? If you get the function mod x, you see you recall the formula of mod x, definition of mod x. Mod x will be x. If x is greater than 0, it will be minus x if x is less than 0. So in this definition, the semblance of right hand limit means 0 plus and 0 minus. 0 plus means I told you that right hand side of 0, here you see a plus. A plus means what? Not plus a, right hand side of a. Suppose this is x is equal to a, that is a plus. From here, it is approaching x is equal to a. This is a minus. A minus, does it mean minus a? No. A minus a means from left hand side of minus, curve is approaching this limit. So from both side they are approaching one finite value, so limit exists if they meet. So here, once you get mod x and once you recall the definition of mod x, then we have to choose 0 plus means right hand side of 0, and for it, what will be the value of this function? We know that if x is greater than 0, then mod x will remain x. Then it is an easy task to cancel it, you will get 1. Now, in case of x tends to 0 minus, 0 minus means left hand side of 0, then mod x will be minus x, cancel it, you will get minus 1. So, right hand limit is plus 1, left hand limit is minus 1. So, they do not converge to a finite limit from both sides of this limiting value. So, you can conclude that limit x tends to 0 plus this is fx not equal to limit x tends to 0 minus fx. So you write limit does not exist. And if you follow last day's class, we got one problem depending on this. The problem seemed to us very easy. It came in JEE, but those who are not aware of this contrast, those who are not aware of the definition of the limit, they had chosen the wrong answer. Because if you get this type root, mod, box, this type function, then existence of limit will be examined first. Now, few more properties were taught. Obviously, limit extends to 0, sin x by x 1, and limit extends to 0, tan x by x also 1. And hope you have gone through the video. There we could establish the formula by using sandwich theorem or squeeze play theorem. What is that? That if there is a function like hx, that is uppermost curve, in lowermost curve there is a function gx, and at the middle fx. Now here this figure depicts what? Fx is squeezed between hx and gx. Now we are taught what? If this is called infimum, minimum, that is maximum, it lies in the middle. If at any particular point the limiting value of minimum and limiting value of supremum are equal, then limiting value of this function also be equal to L. So till this step we could proceed last day.
Yes, sir.
Yes. Hope you can remember. Now we will skip to the next topic. Next topic, first of all, if you are told to divide x to the power n minus a to the power n by x minus a, you will get what? You are taught this thing in synthetic division in class 8. That is x to the power n minus 1. Quotient will be what? Plus x to the power n minus 2a plus x to the power n minus 3a square. And this way, at a stage, x's power is decreasing, a's power is increasing. Okay? That thing you got even in computer. See, a to the power n minus 1. That is the quotient. That is the remainder. So what we have got? X to the power n minus a to the power n by x minus a is what? This is the quotient. By division algorithm, we have got this. Now, you do one thing. You take limit to both sides. Limit of what? Tends to a. You take limit to both sides. Once you take the limit, then left hand side will have no change, but you observe in place of x, if I put a, will that give you a finite or defined value? Yes, because there is nothing in denominator but 1. So we have the free will to put a in place of x, because x tends to a is given. Last day I told you that though x's value is not a but nearest to a, but for the sake of calculation we can put, because where it is terminated we do not know, non-measurable, it is infinitesimally small. So you put a, I have put here a to the power n minus 2 in place of x, a to the power n minus 3 in place of x. In this way, it terminates at a to the power minus 1. Now, these two are in product. You know laws of indices. N minus 2 plus 1, a to the power n minus 1. That also gives you a to the power n minus 1, n minus 3 plus 2, a to the power n minus 1, a to the power n minus 1. So, a to the power n minus 1 recurs how many times? N times, because power is n. So, this value will recur n times, So, I can write n a to the power n minus 1. So, this thing results what? X to the power n minus a to the power n by x minus a, where x tends to a, it results n a to the power n minus 1. Hope you could follow. It is nothing but for division. Now, so one simple use of this formula. Suppose you have got limit x tends to 2, school level sum, x tends to 2, x to the power 5 minus 32 by x minus 2. Okay, so it is a simple school level formula. X tends to 2. Now 32, can it be expressed in terms of some power of 2? Yes. X to the power 5 minus 2 to the power 5 by x minus 2. So, you see, with which formula it is comparable? The formula we have just done. Okay?
Okay.
So this gives you what? N a to the power n minus 1. Here what is n? 5. What is a? 2. So 5, 2 to the power 5 minus 1. 5, 2 to the power 4, that is 80. So a simple example of that formula we have dragged. Now, few series you have to remember, not for board level, but for joint level. But from where this series is coming, you will come to know after completion of Taylor's theorem in class 12. Taylor's theorem will not be there in syllabus. In syllabus, you will have Lagrange's mean value theorem, but its extended version, if teacher wish, they can teach. See, first of all, one expansion e to the power x, it has one expansion, 1 plus x by, this is called factorial sign. Factorial means it is denoted by the exclamatory sign. From the term factor, we have got factorial. x square by factorial 2. Factorial, suppose what is factorial 4? 4 into 3 into 2 into 1. You will be taught this thing in permutation in later. Means the term with which you will be familiar in when you will do permutation. Now x cube by 3 factorial up to infinity. That is expansion of e to the power x. You have to remember this. You can ask me what privilege you will get remembering this. Okay, let's see. This is one formula. Consider this thing is a formula. The derivation of the formula will be shown after completion of Taylor's theorem. Till then, we will restore this in our hard disk, means memory. Understand? So, you bring 1 in left hand side. Drag this 1 in left hand side, and in right hand side, there will be the term left, that is in terms of x. All terms are generated by x. Now, you tell me, in open eye, what can you take common from here?
X.
X. Because you can say a infinity is there. So what? All terms will involve x. So I can take x common. If I take x common, what will be left against it? 1 by. Always remember factorial 1 means 1 only. 1 x by factorial 2 x square by factorial 3 up to infinity. Now, this x, what to be put? Put in the denominator of this. So, what will be left in right hand side? Now, you introduce limit to both sides. Limit, you introduce limit x tends to 0 to both sides. So, in right hand side, barring the leading element 1, other elements are generated by, if put your finger on this number, other elements are generated by x. So, if I put x is equal to 0, will that give you any undefined value? No. So, put 0. So, what will be left? Only 1. So, we have got a new formula, x tends to 0, e to the power x minus 1 is equal to 1. Okay, another formula we have got. Using this expansion, we have got a new formula in limit. One example of such type, see, suppose you have got limit x tends to 0, e to the power mod x minus 1 by x. It is simple board level sum. But once this mod is introduced, then it can come even in JEE level. Understand? So, I told you few minutes back or last day also, once you get mod, then you examine the existence of the limit, so that 0 plus 0 minus will be considered. Let's see, even after examining, if you get left hand and right hand limit equal, then limit will exist, then we'll find its value. So, understand, suppose one patient is shifted to doctor, now or hospital. Now the hospital will admit the patient if the patient is alive. So whether he or she is alive or not, that will be examined. Then the patient will be admitted. Here we'll examine whether limit exists or not. Then we'll find the value. Understand?
Okay, sir.
So here x tends to 0 plus. Once you put x tends to 0 plus, means mod x will be x. And use the formula directly 1. Now when x tends to 0 minus, mod x will be minus x. Can I put 1? No. Why? Because you observe here each power is x. It is divided by x. The variable x at which the limit is found, that is also x. So, but here it is minus x. So bring 1 minus to balance, multiply by minus 1. You can write x tends to 0 means minus x also tends to 0. Now, instead of this, you can put 1. But that minus 1 will remain. So, left hand limit is minus 1. So, right hand limit, RHL, right hand limit 1, left hand limit minus 1. Are they equal? Are they equal? Right hand limit and left hand limit equal?
Yes, sir.
No, not equal. This is plus 1, this is minus 1. So, right hand limit not equal to left hand limit in this case. So, limit does not exist. So, no point of find the value of this limit, because it is examined that right hand limit is 1, left hand limit is minus 1. So, they are not equal. So, we will not find the value of limit. Limit does not exist. Okay?
Okay, sir.
So, e to the power x's value you have got means you are now aware it is x by factorial 1, x square by factorial 2, x cube by factorial 3, x to the power 4 by factorial 4, x to the power 5 by factorial 5, and so on. Now, I am replacing x by ix. I you got in complex number. E to the power ix. So, all x will be replaced by ix.
IX.
Ix by factorial 1, ix whole square by factorial 2, ix whole cube by factorial 3, ix whole to the power 4 by factorial 4, ix whole to the power 5 by factorial 5, and so on. Now, e to the power ix, hope you can remember the term. It refers Euler's form, means cos x plus I sin x. Cos x plus I sin x. Here you observe 1 plus ix by factorial 1. This is I square x square by factorial 2. I cube x cube by factorial 3, I to the power 4 x to the power 4 by factorial 4, I to the power 5 x to the power 5 by factorial 5, and so on. Now what is I square? You got root minus 1. I square is minus 1. So instead of this, I can write minus 1. I cube means I square into I. I square is minus 1, so minus I. Minus I x cube by factorial 3. I to the power 4. I square whole square minus 1 whole square, that is 1 x to the power 4. In the same manner, I to the power 5 will be I, and so on. Now you separate the term which involves I and without I. You first write the term without I, because in complex number the standard form of Euler's are set in this way: cos theta plus I sin theta, polar form. See, I will bring all the terms without I together. Now, from the term which involved I will be taken common. X by factorial 1, x minus x square by factorial 3, x to the power 5 by factorial 5 up to infinity, that is cos x plus I sin x. Now basic of algebra in in complex number, those who are taught complex number, they can do real part is equal to real part, imaginary part is equal to imaginary part. So cos x is equal to and sin x is equal to so these two are expansion of cos x and sin x. So from complex number we have got that. Is it clearly visible? Hope it is clearly visible.
Yes, sir.
Okay. Now, based on this, we'll do one sum. Which is important for JEE mainly, because this series hardly you can use in any school or board level exam. Only for JEE. See, remember this formula. One thing I can do, I can skip the screen. It is given limit x tends to 0. X 1 plus a cos x minus b sin x, that is given. by x cube is equal to 1. That is given. Now, the value of the ordered pair AB is option A minus 5 by 2 minus half, option B option B 5 by 2 3 by 2, option C option D. So these are 4 options. It is pure JEE level question. Now, you have to find A and B. First, we need observation. What to observe? The whole function at the limit extends to 0 converts to a finite value 1, because limit means it must converge to a finite value. Okay. Otherwise,
Okay.
the nomenclature limit will be meaningless. Okay. Why it is called limit? It converts to a value. It has a limiting value. It is a boundary. Yes or no?
Yes, sir.
So, here there are two methods. In one method, we can use differentiation, but it is not taught at the beginning of class 11. We should not use differentiation right now. So we can use this series directly. So cos x's series and sin x's series we have got. You just plug and put there. See the outcome. Hope it is visible.
Yes, sir.
Limit x tends to 0, x 1 plus a. This expansion cos x you plug and put here. In place of cos x, I have put. And in place of sin x also. Sin x's expansion is what? By x cube. That is equal to 1 given. Now, what will be our next step? See, first of all, you separate the term which is See, from here, left part, we have already x outside, and from right part also, later part, from this part, I can take x common. I can take x common, yes or
Yes.
no? And here is also x. So from the total numerator, I can take x common now. From total numerator, I can take x common. See the outcome. If I take x common, what will be left in the bracket? 1 plus a into 1 minus x square by factorial 2 x to the power 4 by factorial 4 minus, I have taken x common from each term and the whole term I have taken x common. So here against x, what will remain? 1. Against x cube, x square. Against x to the power 5, x to the power 4. So what will be left? X cube. That is 1. Hope you could connect yourself to this level. Yes or no?
Yes, sir.
Now, what can I cancel? 1x and another x cancel. That will become x square. Okay. Now, instead of going to next page, let us skip here. After this stage, see, after this stage, what will be our motto? You separate the term which is not involving x. See, where x is not involved, 1, a into 1 minus b into 1. You separate them. One is there, 1 plus a into 1, a minus b is separated. And now the rest part. Rest part means here you are getting 1x square, 1x square. You put them together. See here, minus minus plus. So plus bx square by factorial 3. And here minus ax square by factorial 2. Okay?
Okay, sir.
And other part which is involving x to the power 4 onwards. See, x to the power 4 into a by factorial 4, a by factorial 4, here minus b by factorial 5 onwards, no need to mention. By x square, it will converge to 1. Now you split term wise this by x square. Limit x tends to 0. 1 plus a minus b by x square plus second term by x square. From second term, I can take what common? X square? Yes or no?
Yes, sir.
What will be left in the bracket? I think I have, by mistake, I have written, this is factorial 3. You see, a x square by factorial 2. It must be factorial 2. By x square. And later part, x to the power 4 whatever be in the bracket, that is immaterial, by x square is equal to 1. Draw one demarcation line. Now, you observe, if I put x is equal to 0, it will be undefined, yes or no? Because the
Yes.
numerator is a constant term, yes or no?
Yes, sir.
And denominator is a variable. So if I put 0, it will be undefined, unlimited. But it has a limit. Yes or no? So I can't put 0. Okay? I can't put 0. So what I will do with this? I have to make it disappear. Because if this part exists, then it will contradict that the limit has a finite value 1. Yes or no?
Yes, sir.
So it must be disappeared. When? If 1 plus a minus b is equal to 0. 0 by would be 0. It is not exactly 0. Nearest value to 0 and denominator if 0, then division it will be 0. Yes or no?
Yes, sir.
X square will get cancelled. And later part is generated by x. So if I put x is equal to 0, 0 into something will be 0. So what will be left? B by factorial 3 minus a by factorial 2 is equal to 1. So to make it valid, this thing has to be disappeared. And to make it disappear, the numerator must be equal to 0. And this part obviously 0 because it will be it is the multiple of x square. So if I put 0, 0 into that thing 0, only this constant part will remain and that will be equal to 1. So at last we have got two equation in terms of a and b, and now we will solve it as we used to solve in junior class 9 or 8. Linear equation. See, wait. See, after this stage, we will skip here. First equation is a minus b is equal to minus 1. And second equation, b by factorial 3. Factorial 3 means 3 into 2 into 1, 6. b by 6 minus a by 2 is equal to 1. So, take the LCM, you will get b minus 3a is equal to 6. And here, if I take minus common, b minus a is equal to 1. So, you subtract, b will get cancelled. Then, minus 2a is equal to 5. Minus 2a is equal to 5. We have got a is equal to minus 5 by 2. Once you get a minus 5 by 2, put it in either of these two equations. I am putting in the first equation. Minus 5 by 2 minus b is equal to minus 1. So b is equal to minus 3 by 2. Minus 3 by 2 and minus 5 by 2. Option A is the correct answer. Understand?
Yes, sir.
Okay. Next property.